In the previous question, we had a power company trying to deliver 150,000 watts over a 2 ohm transmission line, exactly like this problem, except they were doing it at 20,000 volts, a fairly high voltage. What happens if we drop the volts to 560? Let's see what happens to our power loss and our efficiency of the system. So, same method. We have our power in and our input voltage, so we'll figure out our overall current because, as I mentioned in the previous video, the current stays constant. So I simply go power total, I total times V total, and I get my total current to be 150,000 divided by 560 volts. That gives me a fairly significant current of 267.9 amps. As opposed to the 7.5 amps before. Now let's work on the power lost in the lines themselves. Now remember, we have to use the equation I squared R because we don't know the voltage across the lines, but we do know the current stays constant. And right away you can see the current is squared, so it has a significant impact. Obviously, if we go from 7.5 amps up to 267.9 amps, the power loss is going to be significantly greater. Which makes sense since current generates heat and we don't want heat. So 267.9 times my resistance, which is 2 ohms, gives me a loss of 1.44 times 10 to the 5 watts. Now, if you recall before, it was only 113 watts was my power loss, so quite a bit of my initial power has been lost in this model. Now, when we want to calculate our efficiency, the efficiency is output over input. My output is 150,000 watts is what I started with, but I lost 144,000 watts, 1.44 times 10 to the 5. Divided by my input power, which was 150,000, and then times 100% to get our percentage. And we end up getting an appalling efficiency of 4.24%. So this model, where we deliver the power at a low voltage and a high current, creates for very inefficient lines. So discuss which mode of power delivery is better. Obviously, we want high voltage. I think of voltage as electric pressure. So we want high electric pressure across the lines, slowly moving a large amount of current, 7.5 amps, slowly moving the current through the lines to the city. So high voltages are better than high currents because they don't generate as much heat.